Hi everyone! Today, we're diving into a common but crucial error message you might encounter in deep learning or GPU programming. Indices should be either on CPU or on the same device as the index tensor. It sounds super technical at first glance, but I promise, it's quite straightforward to understand and simple to fix once you grasp the core concept. We'll break down exactly what this message means, why it pops up, and most importantly, how to resolve it efficiently, ensuring your code runs smoothly. So, let's start with what it actually means. Imagine you have a massive spreadsheet of data, like a giant list of numbers. This spreadsheet is your index tensor, the main block of information you're working with. Now, you want to pick out specific rows or columns from this spreadsheet. The instructions telling you which rows or columns to pick are your indices. The computer needs both your big data spreadsheet and your picking instructions to be in the exact same location. Think of it like this. If your spreadsheet is physically located on your desk, the CPU, then your list of specific items to find must also be on your desk. You can't have the spreadsheet on your desk and the picking list upstairs in another room, the GPU, and expect to work efficiently. They both need to reside either on the CPU, which is your computer's main processor, or on the GPU, your specialized graphics processor designed for heavy numerical computations. Now, why does this error happen? It usually occurs when you inadvertently mix and match where your data lives. For instance, you might have moved your main data tensor, let's call it my_data, to the GPU to speed up calculations using a command like my_data to CUDA. This is great for performance. However, if you then create another tensor, say my_indices, to select specific elements from my_data, my_indices might be created on the CPU by default. When your program tries to use my_indices on CPU to select from my_data on GPU, the system throws this error because the locations don't match. It's like trying to navigate a map that's in your car, while the actual terrain you're trying to navigate is on a different continent. The system prevents this inefficient cross-device communication. Fortunately, fixing this issue is quite simple. The primary solution, especially when you're aiming for GPU acceleration, is to ensure your index tensor is also moved to the GPU. You can achieve this by applying .to CUDA or .CUDA to your index tensor, just as you did with your main data. A very robust way to do this is to explicitly move the index tensor to the same device as your data tensor. For example, if you have data_tensor on a device, you would use index_tensor equals index_tensor to data_tensor device. This ensures they always match. Alternatively, if for some reason you actually want to perform the operation on the CPU, you would move your main data tensor back to the CPU using .to CPU or .cpu. However, this is less common when you're trying to leverage GPU power. The key takeaway is consistency. Both the tensor being indexed and the tensor containing the indices must be on the same computational device. Always make sure they are co-located. This rule exists because moving data between the CPU and GPU is a slow operation, a significant bottleneck that can negate any speed benefits of using the GPU. By enforcing this rule, the system encourages you to manage your data locations explicitly, leading to more efficient and faster deep learning models. So, the next time you encounter that specific error message, you'll know exactly what's going on and how to swiftly resolve it. Remember, keep your data and its indices on the same device, whether that's the CPU or the GPU. This small but critical detail will help you avoid frustrating errors and keep your deep learning projects running smoothly and efficiently. Thanks so much for watching and spending some time with me today. If you found this explanation helpful and easy to understand, please give this video a big thumbs up. And don't forget to subscribe to the channel for more practical tips, tricks, and explanations on deep learning, programming, and all things tech. Your support helps us create more content like this. See you in the next